Hello everyone, my name is Prasoon Diwakar. I'm a Senior Research Associate at the Center for Materials Under Extreme Environment in Nuclear Engineering Department at Purdue University. So today I'm going to talk about PlasMat, the idea which we have come up with, and the main goal for PlasMat is plasma technologies for healthier tomorrow. So one of the main reasons we came up with this idea was one of the main problems which we face is the cancer. It's one of the leading causes of death throughout US as well throughout the world, and we need solutions. We need solutions for how we can effectively treat cancer, and it affects the life of the people who are affected as well as the families, and it's a great financial burden on the family as well as society. And so we want to come up with the solutions. And the current state of art for the cancer treatment usually involves chemotherapy, radiation, and surgery. One of the main issues with these techniques are there are a lot of side effects, such as the weakening of the immune system. They are very highly toxic, which affects the health of the person, not because of the cancer, but because of other issues which arise due to the weakening of the immune systems. And it's sometimes ineffective. The treatment itself is it's not effective for all kinds of cancer, and it's also very expensive. So there is definitely a need for the novel cancer treatment which can get rid of all these side effects and can be effective, efficient, cost effective, reduce toxicity, and is also portable and flexible to be included in the current hospital system, which can be easily embedded in the system. So with PlasMat, the technology which I am going to talk about, it provides an efficient, non-toxic and cost-effective approach for treatment of cancers without affecting the healthy cells. So the technology is quite innovative and simple in a way, because what we are trying to combine with different aspects and different technologies and come up with a novel treatment. So there are two things which I'm going to talk about. One is cold atmospheric plasma, which is a plasma source which generates various reactive species. For example, reactive oxidative species, nitrogens, nitrogen oxides, RONs, and ultraviolet radiations. And this has been shown to be effective in killing cancer cells, but it's not able to penetrate to the cancer cells. And there are other techniques, for example, electric field. You can apply electric field to the cells, or you can apply laser, which helps in opening of the pores of the cells. So if you combine this, what happens is we open up the membrane of the cells using either the electric field or the laser or the combination of both, and then we apply the cold atmospheric plasma, and which supplies all these reactive species, and it can penetrate, go inside the specific cancer cells. And this lead to death of the cancer cells occurs when this ROS and ROS, all these species go inside the cells, and when they reach the critical threshold level, the cell dies. While the healthy cells, after a while, they recover back, so healthy cells are not affected, but the tumorous and the cancer cells die, and that's have been shown to be very, very effective. So this is one of the main innovative ideas which we have developed, and it has been shown to be effective in various line of cancer cells. And so this is some of the results which we have come up with using this technique. As you can show here, this is the cell viability, the number of the percent of the cells which are alive after the treatment, and you can see by combining various techniques, the cold atmospheric plasma and the electrical field or various combination, we have been able to reduce, for example, the prostate cancer cell to about, the cells are dead, about 80% of cells are dead, the cancer cells are dead. We have been effectively able to kill all the cancer cells, and this video basically shows here. This video basically shows here, like, as a function of time. So we treated the cells and left it there for about 45 hours. As a function of time, we can see the cells turning green. The green shows the signal the cells are dying. And after 45 hours, we can effectively see that all the cancer cells are dead. And this has shown that there's a lot of promise for this technique, and we want to develop it further. We want to take it out, test it on different lines of cells, maybe different like animal testing, and then further clinical trials. That's the goal to achieve in the next coming days. So as we know that cancer research is a huge industry, 110 to 112 billion dollar industry, and about $5 billion of this is for cancer therapeutics. So we see there is a big market which can be captured if this technique comes from market. And we have filed a provisional patent by PRF. It has already been filed. And the key task, the next step, what we want to do is to do some trials on different cell lines and also test on animals and also apply for the FDA approval. And the key customers which we have identified by talking to various people, various agencies, the key customers for this kind of system will be hospital administrators, the insurance companies, because they also reduce their burden on the financial burden, and also the oncology researchers, because they want to use it for different kind of applications. And the key third-party suppliers are the Neoplast tools, which supplied us the plasma, but others are small manufacturers which we'll be using for developing these systems. And the current key team members include myself, Prasoon Diwakar, then Ahmed Hasnain, he's the Director of Center for Materials and Extreme Environment, and other graduate and undergraduate students. And as we get more support and more supporting results, we'll be growing in further coming years. And of course, the Purdue oncology researchers we have been collaborating with. And ultimately, for the final product, what we're envisioning is an effective and efficient portable system which will be cost effective for the users, which users include the patients, the hospitals, and it will be affordable, and it can be easily integrated with the existing medical technologies which in the hospitals. It will not be a costly affair for the hospital to embed in the system. And the technology has also can be extended for different market areas. It's not limited to cancer, but we can also use it for food safety, for treatment of wounds, for disinfection of instruments while operating for the operations. So there are different applications which can be extended and which we can work for. But so these are we want to start with the cancer research, and then we want to pursue further for different areas as we go along. Thank you for your patience.